Good morning, third year. Hope we're all doing well. Hope we enjoyed the lovely weather this weekend. Today's going to be some new content. We've more or less finished the first unit in National 5, but I'm just going to try and take us through this lesson myself. There's going to be points in this video that I'm going to ask you to pause the video to copy some things down. I'll ask you to pause it and have a go at an example and so on. So please do follow that. It will give you the best chance of trying to access the questions that are at the end of this little presentation. Can I ask you please to put the heading Rearranging Formula to Solve Problems? Okay, rearranging formula to solve problems. I'll tell you when I want you to specifically copy some things down. Right, so far in National 5, I don't want you to copy this down. So far in National 5, we've learned quite a lot of new formula. We've learned, when we did arcs and sectors, we learned how to calculate the length of an arc. We do angle over 360 times pi d. We learned how to work out the area of a sector. Angle over 360 times pi r squared. Those were two standard results. When we did volume, we learned that the volume of a cylinder is pi r squared h. Of a cone, a third pi r squared h. A pyramid, a third times the area of the cross section times the height. And the volume of a sphere, 4/3 pi r cubed. Okay, so those are all standard results that we've learned, and we've more or less looked at the bog standard questions. Calculate the volume of this cylinder when the radius is blah and the height is blah. Very straightforward, just plug it into a calculator. But sometimes these questions can be twisted slightly. There's two examples here I want you to have a look at. I'm not going to ask you to copy any of this down yet. So shown is a sector of a circle, calculate the length of the arc. Shown as a sector, the arc length is 4.4 centimetres, calculate the size of the angle. So notice how both of these questions on the surface appear the same. I'll try and see if I can get a pen here. Notice how this example on the left here, it just says calculate the length of the arc. Okay, very bog standard question, nothing fancy there. Just a bog standard, calculate the arc length. Okay, but in this question on the right here, it says calculate the size of the angle, and we're told the arc length. That's interesting. If we just have a look at the example left, once again, not asking you to copy this down. Okay, this is just stuff that I assume that we know. So this is a bog standard calculate the arc length question. So we would write down our formula, angle over 360 times pi d. The angle is 60 degrees. The diameter, remember the diameter would go the full way across, so the diameter would be 24. We would multiply that just on a calculator, and we would do any appropriate rounding. Okay, nothing fancy there, very bog standard. But what if we had a question like this one on the right hand side? What if we're told the arc length and we want to work out the size of the angle? Let's have a look at this one. Okay, so we have got a sector here of a circle. Okay, we are told that the arc length is 4.4 centimetres. We want to work out the angle. So notice how essentially what we need to work out, and if I just get my highlighter here, we want to somehow work out the angle in this problem. Okay, so let's have a look here. So calculate the size of the angle given that we're given that arc length. So because we are told what the arc length is, the first thing I would do, guys, is I would write down my arc length formula. Arc length is angle over 360 times pi times the diameter. So like I said here, we want to work that out. What's the angle? Next thing we're going to do is let's put in what we know. We know that the arc length is 4.4. So see, instead of writing arc length, I can write 4.4. Okay, once again, I'll try and do this in red pen. Okay, we are told that the arc length is 4.4, so we replace the arc length with 4.4, which we've done there. That's a terrible arrow. Okay, so I will get rid of that. What we want to do is we want to somehow rearrange this formula, this equation, to try and make it to be angle equals. I need you to think back to, for example, when we would solve equations. 2x equals 30. If it was 2x equals 30, you would divide both sides by 2. If it was x divided by 2 equals 10, well, we would need to do the opposite of dividing by 2, which is multiplying by 2. So we would times both sides by 2. So what we're essentially going to have to do here is we're going to need to do some rearranging. So notice here, I want to have angle equals as my final line. The first thing I note is that the angle is being divided by 360. The opposite of dividing by 360 is timesing both sides by 360. I'll get rid of that. Okay, so I've times both sides by 360. I've then got angle times pi times 12. So notice how both of those things are multiplying the angle. So the opposite of multiplying is dividing. So my next line would be angle equals 360 times 4.4 over pi times 12. Okay, I'll just try and show what I've done there. I'll get a green highlighter. So notice here that at this stage, this was multiplying the angle, so we divide both sides by that. On our calculator, and we would get that result there. Can I ask you please to pause this video and copy that example down? Okay, so you should have just paused that and copied that example down. Once you've done that, can I ask you please to have a go at this question here on the right hand side? Copy the example down, pause, and have a go. Okay, so you should have just had a go at that problem there. I'll take you through the solution for it. Like I say, you should have already had a go at this. So we're told that the arc length is 56, calculate the angle. So we write down our arc length formula. We're told the arc length is 56, so we do 56. Angle over 360 times pi times the diameter. The diameter is 2 lots of 27 is 54. So we want to make the angle the subject of the formula. So the first thing we do is we times both sides by 360. And then we would divide by pi times 54. Which should give us an answer of 118.84 degrees. Once again, make sure please you've got everything on this slide copied down, if you haven't had a go at it already. Guys, I've not given that a number, but can you please call that example 1 and example 2? There's quite a few examples here. Okay, let's call this example 3. Calculate the height. So here we've got a cylinder, like a Pringles tube. So let's have a think about this. So we've got the volume of a cylinder. So the volume of a cylinder is pi r squared h. The area of the face times the height, pi r squared h. But this time we want to work out the height. Okay, we're told the volume. The volume is 800. Okay, so instead of just working out the volume as we would, we know what the volume is. So this is where this next line is going to come from. So 800 is equal to pi times 4.5 squared times the height. Remember, the radius just goes half the way across. We want to work out the height, so our final we want it to be h equals. Notice here that the height is being multiplied by pi times 4.5 squared. So the opposite of multiplying would be to divide both sides by that. And we would get 800 divided by pi times 4.5 squared, which is 4.0028, so let's just call it 4 centimetres. So here we've worked backwards to find the height. Pause the video and copy that example down. That's example 3. Okay, you should have just copied down example 3. Having done that, can you please have a go at example 4? Copy that example, have a go at it please. Okay, so you should have just had a go at example 4. We'll take you through the solution now. So we're told we've got a cylinder, we're told the volume. The volume of a cylinder is pi r squared times the height. We're told the volume is 1,600. So 1,600 equals pi times 6 squared times the height. Notice how in this problem we are already given the radius. In this one we had to half it, but we're given it there. So, okay, so pi times 6 squared times the height. Notice here that the height is being multiplied by pi times 6 squared. The opposite of multiplying is dividing. So we would divide both sides and we would get the height is 1,600 divided by pi times 6 squared, which is 14.1 centimetres once we've rounded it. Please make sure that you have copied down example 3 and 4 into your jotter. Sometimes a question will ask you to work out the radius. For example, let's have a look at this. Okay, so we've got a cylinder. We're told the volume of the cylinder. We're told the height of the cylinder, and we want to work out x. And we have to have a look there carefully. X is the radius because it's only going half the way across. So first thing, it's a cylinder, so I'd write down the volume of a cylinder. And I would substitute in what I have. So the volume's 9,000. The radius is x. So see, instead of writing r, I'm going to write x like we've got there. So this is where my next line of working comes in. 9,000 equals pi times x squared times 12. I'm just substituting in what we know. We want to work out what is x squared, what is the radius squared. So notice at the moment that is being multiplied by pi and 12. Hopefully you can see that. X squared is being multiplied by pi and 12. Okay, so the opposite of multiplication is division. Okay, so x squared is 9,000 divided by pi times 12. I can just do that in a calculator. That's what x squared is. If you think back to Pythagoras, at this point here, you would take the square root. Okay, so on a calculator, you could just do square root and then press the answer button. So if you take the square root, we would get the radius is 15.5 centimetres once we have rounded it. Okay, please copy this example down. This is a really important one. Copy this example down and pause the video. Okay, so the radius is 15.5 centimetres. Okay, last slide. This is what I want you to have a go at today. There are 7 questions altogether. So 1, 2, 3, 4, 5, 6, 7. In each of these questions you're asked to work backwards. Basic strategy. If it tells you the arc length, write down your arc length formula. Here we've got a cylinder, write down your cylinder formula. Here you've got an area question, write down the area of a sector formula. Here we've got a cone, write down the cone formula. Here we've got a pyramid, write down the pyramid formula. And you need to rearrange it to try and figure out either the angle, the height, the diameter, the radius. I have given you the answers to all of these questions here.